Here we go with our lesson practice for lesson 5. This is going to be using the postulate and the theorems from lesson 5 to answer these questions. Let's start with letter A. If the horizontal planes are parallel, so that's plane BAF and the plane that contains line CD but doesn't have another point on it for me to identify it. So you can see the two horizontal planes. We can identify them as horizontal planes in the picture. They're parallel. We need to identify the lines that are parallel to one another. Now, this is interesting, okay? Because we could probably say that line AB and line EF are parallel, but we would have to do some extra proving to do that. So I'm just going to identify the lines that on their face are parallel, and that's what the book has as an answer too. So I know that because the planes are parallel, that any lines that exist at the intersection of an intersecting plane also have to be parallel. And to make that supposition, I'm using Theorem 5.1. In Theorem 5.1, we learned that if two parallel planes are cut by a third plane, the lines of intersection are also parallel. So I have these two parallel planes. I see that the plane CEF cuts through them. That means that the lines CD, which is one of the lines of intersection, and the line EF have to be parallel to each other. So I'm going to note that as a pair of parallel lines, okay? So for letter A, line EF, I'm just going to say line EF instead of putting the arrow over the top for now. We've got so much to do here. And line CD are parallel. Also, line CD and line AB are parallel, because you see that I have another plane that cuts through the bottom plane and top plane. And then if EF is parallel to CD and AB is parallel to CD, I know those are going the same direction. I could also prove that those two lines are parallel because they're going the same direction. They have to exist in the same plane, in a plane. And I see that they're in a plane together on top. So I'm sure there's a way I could prove that AB and EF are parallel, but you know what? We're going to have to wait to do that until we learn about geometric proofs in a future lesson. So we're going to wait with that one. We're just going to use our Theorem 5.1 to identify parallel lines, and those are the two that we can identify from Theorem 5.1. All right, let's look at the complicated figure down below letter B. In that figure, CD, line CD is parallel to GH. We have that indicated for us by markers, parallel markers. And CD is perpendicular to AB. What is the relationship between AB and GH? Well, we know that AB and GH must be perpendicular. And the reason for that goes back to, and let me just look at my theorems here for a second, and feel free to refer to theorems. Let's see. Let's say Theorem 5.2. If two lines in a plane are perpendicular to the same line, they are parallel to each other. No, that doesn't really apply. What about Theorem 5.3? In a plane, if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other one. Well, that seems to fit. Let me just double check. Theorem 5.3. Here I have a plane with all these figures in it that exist in the same plane. If a line is perpendicular to one of two parallel lines, here I have AB is perpendicular to CD, and CD is parallel to GH. And if that first line that I mentioned, AB, is perpendicular to one parallel line, then it has to be perpendicular to the other parallel line, GH. So that's how I know it's perpendicular. So I'm going to say perpendicular, and even though it doesn't require me to do it, I'm going to mention Theorem 5.2 did not apply, but 5.3 did. And that's what's going to happen in these problems. You're going to look through your theorems. You're going to find something, those don't really have to do with this, but you will find a theorem that helps you answer the question. All right, letter C. in this one, if RS is perpendicular to XY and VW is perpendicular to XY, what is the relationship between RS and VW? So I have a line perpendicular to another line perpendicular to that same line. Well, I know just looking at it that those two are going to be parallel. Let me see if I can support that with a theorem, though. If the two lines are perpendicular, I need to find something about two lines being perpendicular, parallel or perpendicular. I wonder about the parallel postulate. No. Let's see. If two lines are perpendicular to the same line, they are parallel to each other. What about theorem 5.2, that one that didn't work before? If two lines are perpendicular to the same line, RS, VW, both perpendicular to XY, that means they are parallel to each other. Wow, I figured out that must be theorem 5.2. And I did that by inspection. I noticed it wasn't any of the other postulates or theorems. It must have been that one. All right, let's look at letter D. What is the relationship among the angles at the points of intersection of RS, TU, and VW, RS, TU, and VW with XY? All right, so the angles at the points of intersection. So the answer in the book is impossibly hard to guess. But this is trying to refer back to the theorem, let's see, 5.6, that all right angles are congruent. So it's trying to get you to say that they're all congruent. It's just not clear that that's the answer that they're looking for. If I were asking this question, I would do it a lot more clearly. So all of the angles are congruent because they are all right angles. And we know that from another theorem, like all of the angles have to be congruent because the adjacent angles have to be congruent. Remember, theorem 5.4 said that if two lines are perpendicular, they form congruent adjacent angles. So all these perpendicular signs must be next to more, or right angle signs, I guess, must be next to right angle signs, and those right angle signs must be next to right angle signs, and those right angle signs must be next to right angle signs. So all of those angles have to be right angles, and they're all congruent because they are all right angles. So I use theorem 5.4 and theorem 5.6 in answering that question. Let's take a look at E. Letter E, if line XY goes through point M and XY is parallel to CD, how do you know that JK is not parallel to CD? Well, actually, JK is parallel to CD. JK, sorry. Anyway, what we actually know to be true, according to the parallel postulate, through a point not on a line, there exists exactly one point through the line that is parallel to the line, exactly one line that is, exactly one line through the point that is parallel to the line. So according to postulate 10, the parallel postulate, there can only be one line through point M parallel to line CD. I'm going to write that out so you can see how this one would look. So I'd say according to postulate 10, I could call it the parallel postulate, there can only be one line through point M parallel to line CD. I know that JK, therefore, and so JK cannot be another parallel line because XY is already the one parallel line. There we go. That answers the question. And then letter F, Carlotta is assembling the floorboards of her deck. How can she be sure that all the boards are parallel to one another? So as she lays each parallel board, we're going to assume that the first two floorboards are parallel. Okay? According to theorem 5.7, if two lines are parallel to the same line, then they are parallel to one another. So I'm going to say, according to theorem 5, 7, if two lines are parallel to the same line, they are parallel to one another. So as long as Carlotta keeps laying the boards parallel to the previous board, they will be parallel to the original board, which is her goal, right? She wants all of them to be parallel. How is she going to make sure they're parallel? She's going to make sure that they're parallel to the original board. And how does she keep them parallel to the original board? Making sure they're parallel to each other, okay? And that's the transitive property of parallel lines. That's how she's going to do it. So according to the book says if all adjacent boards are parallel to each other, the boards will also be parallel to one another. All of them will be parallel to one another according to that transitive property of parallel lines. And that is how you answer these kinds of questions. Notice that I regularly went back to our original postulates and theorems, and that's what you should do too as you answer questions for lesson 5. All right, you ready to get started? Let's go.